Okay, let's get started. Good morning, everyone. So welcome to today's session, and we'll be talking about. Can you hear me? Good morning, everyone. Welcome to today's session. I'll be talking about AWS Transit Gateway. Would actually simplify it. We're taking into our really the use case, and also we justify every of our implementation. Why are we doing this and this? Is there any alternative for this and this? And why is even Transit Gateway? So we'll be giving a more intrinsic implementation into Transit Gateway. And believe me, if you are working on a production network on AWS, Transit Gateway is a must knowledge for you. It's something that you can't avoid it. Maybe your company has a lot of VPC or has a lot of VPN connections, even if it's even has a direct connect in terms of this line dedicated connection. So there is no way you would have to encounter AWS Transit Gateway because it's a very powerful and major service on AWS. So this is about me. I think everybody knows me. I think it's a new picture, Sha. It's different from the old one. So let's go. So today, what I will be discussing, we'll be discussing the bottleneck of VPC peering. And then last week, we discussed about VPC peering. We implemented it, we saw the action, and we also see how it works. And today, we'll be discussing about Transit Gateway and why are we using it. And also, there's something we call attachments. Those are components of the Transit Gateway. So we'll be talking about the routes, and also don't forget our use case that we are using, the Solis app implementation. So we'll continue this today as well using the Transit Gateway. And how do we ensure communication across VPC using the Transit Gateway? So those are the things we'll be looking at today, one after the other. So let's get started. So VPC peering, we did it last weekend. So VPC peering is more or less like a communication between two VPC. So we said that it's not transitive, it's private. You need to manually update the routes, and also you cannot use overlap CIDR blocks. And another major thing there is that it's not transitive. So I gave an scenario last week that okay, if I have a peering between A and B, and I have a peering between A and C, so that doesn't mean that there's a connection between B and C. So which means that the peering is just bidirectional from A to B, from B to A. That's all. So it's not like it's more like a transit or something like a gateway to another guy. So that's what we said about it. So this kind of pain point, this kind of bottleneck, so that takes us along. Okay, maybe your company has something we're talking about. You have 10 VPC. So at the end of the day, and you want to ensure communications around that 10 VPC. So there is a formula we use. So this formula is that if you have a 10 VPC, you have about 45 VPC peering. I don't know how you want to do that too. That is more like like a 3 days job, creating VPC peering for like 45 times. That's gonna take a long while. So you can't even. It's not something that worth your time and your energy to start implementing 45 VPC peering. So, and this is the formula. So, and there is something on AWS, you are maxed to 125 VPC peering. So you can't do more than 125. So now let's put in our formula. Assuming you have 100 VPC, can somebody tell me the number of VPC peering you'll be having? Fastest answer. Who wants to be a millionaire? Fastest answer. This is I think it's mathematics 101. Okay, let's calculate it. Let's be fast. Assuming your number of VPC is 100, and what's the number of VPC peering you'll be having? Drop your comments on the session. Drop your answers. I want the fastest answer. You can unmute yourself and talk. If this one wants to be a millionaire, nobody will get here.
No, 90.
I'm seeing 4950 on the chat too.
It's not 90.
Somebody said it's not 90. Another answer again. I think we only got 2 responses. Anybody again? I hope you get my question. Like, assuming you have 100 VPC, What's the number of VPC peering you will have? Let's use the formula on this
Okay,
on
100.
my screen. Yes, 100.
4,950.
Yes, Gabriel is just booting up. 4950.
4950.
4950. I can see Bowie as well. People like saying that John means this thing. No? So 4950. So you'll be having about 4950 VPC peering. So in this regard now, you can see that if you have 4950 peering, how are you going to implement it? Number one, how are you going to do for 4050 peering? That's number one. Number two, how do you do it? Because AWS has marked it that okay, you can't have more than 125 VCP peering in your per VPC. So your VPC cannot peer more than 125 connection. So automatically, this is a pain point. This is an issue which needs to be resolved. So that's why AWS technical teams now comes to what we call VPC peering, VPC Transit Gateway. So now this is the Transit Gateway, the game changer. Transit Gateway is just like a centralized hub, and it performs some kind of magical features. For example, it scales to over 5,000 VPC. It scales up to 5,000 VPC, number one. Number two is a centralized routing. It's also transitive. It supports multi-region, and it supports direct connect and VPN. You know, the other guy, which is the VPC PNE, it only supports VPC attached, VPC only. But this new guy supports direct connect and also supports VPN. And aside that, it propagates route automatically. So those are the features of this new guy. And it acts like a single gateway, just a single guy doing all this stuff centrally. So this is how it looks like. So from here, you use your VPC. These are the VPC, these are the VPC, these are the VPC, these are the VPC. So it connects all these VPC together, irrespective of the region they are. So it's a multi-region device. And as well, this is your VPN, side-to-side VPN that connects to your on-prem. And as well, this is the direct connect gateway. Direct connect gateway is a leased line, dedicated leased line that is connected to AWS. The VPN part is over the internet. It's like over internet. So in the situation whereby your company wants like something like a direct connect that you need to plug in from your router to the AWS router at a particular LOA center. So something like a physical connection to do that, you can have a very trusted connection in terms of the bandwidth. I think we have 1 gig, 10 gig, and all of that. So this is the direct connect. So it's more like a PTP peering. It's from your own router down here to direct connect. And this, so you might not be able to practicalize this direct connect, but I can explain it because it requires like a dedicated connection. I get it. So this transit gateway can also connect to your direct connect. It can attach your direct connect. So this guy gives the overview of what the transit gateway can do in overall, all the connection it can do. Hi, John, you have a question?
No, don't worry, you can proceed.
Okay.
Thank you.
So, what are your limits using transit gateway? What are the limits to things we can do? So it can only use 5 transit gateway per account. And also, it supports over 10,000 routes. You know, the last time I was saying that on your route table, your VPC support only 100, right? So, and our last class, you know, we need to start creating a route table for each of those guys one after the other on the PMA. So at the end of the day, 100 is very, very, very little, like in terms of the number of routes. But this guy support over 10,000 routes and also 5,000 transit gateway attachments. I will explain these attachments in my next section, which automatically means VPC. Do you understand? So it has a very high bandwidth in terms of your the bandwidth, that's 50. And also for the VPN connection, it has like 1.25 for the VPN. So now what is attachment? So there are components of transit gateway. Number one, attachment. Attachment is what is connecting, what is referenced. For example, what are the network connecting to the internet gateway and to the transit gateway? That's the attachments. For example, sorry, using this terminology. Attachments, something that you attach something. I get me. So transit gateway is like a body. So what are you attaching to it? What are you putting to it? Maybe like people female that does their hair, they attach something to their hair. So let's see transit gateway as their hair, like the hair that the woman wants to plait. So those attachments they are attaching are the VPC, attaching to that transit gateway. So number one attachment we can do is the VPC. VPC, the virtual private cloud, is the number one attachment you can attach to your transit gateway. Number two, VPN, direct connect connection. VPN, your site-to-site connection. So it's another attachment you can put to your transit gateway. Your direct connect gateway, I'm talking in terms of your leased line connection, your dedicated connection to AWS. You can attach it to the transit gateway. And also you can do transit gateway peering. So in terms of maybe you are trying to do an high availability architecture that you need to transit gateway, you can pair them together as well. So those are the kind of attachments you will be discussing on this session. But today we focus on VPC attachments. But in next class, we'll try to touch VPN attachment. But everything works on the same fundamentals, on the same first principle. So that's why just try get the fundamentals right today. So any other thing along the line, just more or less like we are adding some kind of layers to it. So the other component here is routes. Some people call it route, some people call it route table. So route tables define how the traffic flows between your attachments. Maybe you have VPC attachment, you have maybe like 10 VPC attachments. So how do you want your traffic to flow between those attachments? How do you plan it? So that's what they call the route. So the transit gateway manages the route. So there is an option for default route table. So once you create a transit gateway first touch like this, it's going to give you a default route table. That's what they are going to give you. And also you can create your own customized one. So many companies even delete the default one and try to customize their own route table based on their own traffic pattern. Maybe I want VPN, maybe I want site A to connect to site B in a different region. Maybe I want VPN B to connect to VPC A. Those kind of specific connection based on your own choice and your own design. That's where you use the multiple route table selection. So go to that practically. And the last one is propagation. So propagation is what makes this guy a game changer, because it's going to automatically propagate the route. Once you've already put the route table there, it's going to learn the route automatically and inject it to the attachment. So the only thing you need to do is maybe on the VPC route table, I need to adjust it one way or the other. That's what you need to do. Anything aside that, this guy automatically propagates. There's a way to include automatically propagation to your route table. I will show you as well. But what I'm saying this way is that it's going to automatically propagate this route. That's that's one of the features, the components of transit gateway. You might not get it very clear now. Yeah, it's fine. But I'm just trying to take it on a theoretical level before we start opening our console. So now let's come into our use case. This is what we are doing since some weeks ago. So I think every one of us know that we have the web VPC, database VPC, and backend VPC. So what this is, let me just try to go over it in case of people that are not in the last session. So we have a company, so they want to implement an infrastructure. So as a cloud network engineer or the network engineer, you are meant to set up the infrastructure for them. So they said they want 3 VPC, or based on your design, you see that okay, it's 3 VPCs that will be suitable for this architecture, just to make sure there is the proper segmentation. So, and the first thing is the compliance. Okay, the IT compliance said that okay, your region must be in EU West 1. Anything you are doing must be within Europe. That one is noted. The other one is that you create your VPC. And the third thing is that for instance, in each VPC, just to ensure that, okay, let's test connectivity from each of the VPC. So we're going to test the connectivity. So the number one thing we're going to do is that we're going to even implement the default route table. Let's see how the default route table on Transit Gateway works. After that, we now start implementing the interconnection. We now start isolating. Okay, I want VPC, web app VPC to reach backend VPC only. Then I also want backend VPC to reach database VPC only. So those are the kind of the custom route tables we'll be looking at. But initially, we're going to investigate and look at the default route table of Transit Gateway. So this is our VPC side range. I think we all agree to this, so it's fine. So we have this side range for each of our VPC, and also this is the diagram. I just put up something very light. So this is how it works. So people coming from the internet, they will go. They're going to be exposed to your front-end VPC. Why your resources in your front-end VPC, which is the web app VPC, will be able to communicate to the back-end VPC. Back-end VPC is where you have your business logic, maybe your Java or your Python code or your Flask. But this front-end is more like your Node.js or something like that. So this back-end VPC might even be your Kubernetes cluster, where you are calling some kind of API from your front-end VPC here. So the VPC, front-end VPC wants to communicate to back-end VPC. And also the back-end VPC needs to call the database. Maybe you are using MongoDB or you are using MySQL or Microsoft SQL. So the database is here. So, we are trying to do three things now. By default, we want three of them to communicate. That's the first thing. Second thing is that we want VPC, front-end VPC, to be able to talk to back-end VPC. I get it. And the third one is that we want back-end VPC to be able to communicate, maybe ping, maybe reach a particular port based on the developer features, or it depends. So we just need communication, and I'll explain that the last class. The security group, I explain security group and network is you understand. So what I want to do is that, so for now, we'll be testing with ping. Now let's take it that we'll testing only with ping for now, but we can still move ahead later. But those are the 3 points we'll be looking at today. We'll be looking at the default route table. I want 3 of them to communicate together. I want to be able to ping all of them from each their VPC. I want to be able to communicate from front end to back end and from back end to database. Let's go. So this is how we design our VPC. I'm sure I think we all get this. So this is the VPC name, the CIDR block, the region. So let's assume all of them are in the same region, EU West 1. And also, the last session in terms of our public and private subnets, how we designed it. Okay, let's give the public subnet, the third octet should be odd number. Why for the private subnet, the third octet should be an even number. It's just a design strategy for a greenfield network. So just a design strategy. There's nothing, it's not like a must or something. It depends on your own discretion. So this is all we have at the end of the day. And we're able to implement this in last class. I'm very sure. I don't want us to go back and start creating VPC and all of that. So I believe we all have it already. Create the VPC, create net, and create the route table. So if you don't get it, you can just, maybe after the session, and just go back to the previous video, the last video we had, and just check through it. But for today, I will explain our private route table and our public route table. What differentiates them, maybe in terms of of what is there. Public subnets are subnets that can reach the internet. That's where you have your internet gateway. So, but private subnets are subnets that can't reach the internet directly. They don't have the access to go to the internet. They need the help of a guy called NAT gateway. So something like your database, it cannot be exposed over the internet. So it needs to be somewhere in your private subnet. But something like your web server, something people need to access over the internet, um, it should be on the public subnets. Maybe you are implementing a private EKS cluster. You don't need internet. You just need you can put it on a private subnet so that people from internet will be able to access your environment. So there are other kind of architecture in terms of choosing, okay, what are the things I need to put on my private subnet? What are the things I need to put on my public subnet? But I think we all have this already. So this is all. Now let's start. Let me try to share my screen and we'll start this session. So I want to log into my AWS account. Let me have my MFA. So if you don't have an AWS account now, you can also check previous sections we have how to create your AWS account, how to attach an MFA, and all of that. So this is the account we are using. So you can, from here, you can see that I'm in EU West 1 region. We have a lot of region in AWS, and we're just using this as a practical. So we have Paris, we have London, we have US East 1, US East 2, we have the Mumbai, and all of that. I will discuss about this region and the availability zone. The reason why you need to choose some region, maybe based on data compliance, based on latency, and all of that. So these are the VPC we have. So you can see we have all these VPC. These are the subnets. 10200, the web app, the backend, and database. We all have this. And also we have the route table as well. You know, our last session we said we don't have a public route table for our database because we don't want it to go to the internet. So now we don't even want our database to the internet. So we don't have a public route table for it. But for the web app public route table, you can see that there's a default route that goes to the internet. Same thing as well for the backend. Backend as well. There's a default route that also goes to the internet. So we have the internet gateway. You know, we explained that the internet gateway is the gateway that helps your VPC to go to the internet to be able to reach any public exposed endpoints or URL. So let's go to this session. I think we're moving fast. I like it. So where am I going? So this is here we are. So Transit Gateway. So you just click on Transit Gateway here. And next week, by God's grace, I'm going to do all these things with Terraform. So that's what the same way we create VPC and all of that with Terraform. I'm going to use this as with Terraform as well by next week. So, but I'll go to the GUI today. So this is the Transit Gateway. And let me start. So I want to create a Transit Gateway. Now, you know, I've explained what a Transit Gateway means and all. So let's create a Transit Gateway. Let's call it Solace or Solace app. Maybe your organization name, Solace app TGW. TGW means that Transit Gateway. Instead of writing Transit Gateway in full, I just put TGW. And description, you can just say Transit Gateway for Solace app. So this is situation whereby you can see that there is ASN. So people that are not, I don't want to go into this for now. So all these ASN parts, BGP, everything. So let's put that one aside for now. You understand? Let's put all those ones aside for now. So you can see that there's a way to do default route table association, default route table propagation. So this we are creating a default route table now. A default okay, sorry about that. Sorry about that. I think it's better now, right? Sorry. So this is the transit gateway. You don't need the ASN for now. This ASN is used for another implementation. So you don't need to put it there for now. And this is what I'm saying. These are the two things: default route table association, default route table propagation. So this is when it automatically updates the route tables and route propagation. So this is all you need to do. You just need to put the name. That's all for now. And just create the backup. Sorry for using that code switching. So I've created my transit gateway. It might take a time to come up. Let's just give it some time. It's pending. So I'm just kind of refresh and see. So on that note, let me just try and bring up my EC2 instance. Last week we created 3 EC2 instances, each instance in each of the VPC. So it might take a while for I think it's available now. Interesting. So we've created transit gateway. So the next thing for us to do now is to create the attachment. That's the next thing to do. So what you do now is that you create the attachment one after the other. I've explained that the attachment can be a VPC attachment, it can be a VPN attachment, it can be a direct connect gateway attachment. But with our use case now, we are focusing only on VPC attachment. So just click on create attachment. So we can call it, what's it? Web app attachments. I get it. So there's a way you need to now reference it. It's an attachment. So you need to reference it to the transit gateway that you want to attach it to. So you click on it. So different type of attachment you can see. The VPC, the VPN connection. This one is a direct connect connection. So you click on the VPC attachment. And you reference the VPC ID. The VPC ID for web app, we've created the VPC. So we also reference it as well. This is web app VPC. And also the subnet. So these are the subnets that are actually attached. So there's a way it depends. You can put in more subnets. You can add your subnet. So it depends. So we are still going to reference all the subnets. We'll see it later. So let's so you can click on the subnets that you want. You can actually click. Maybe you want to propagate the public subnets, or you want to propagate the private subnet. So I can say, okay, maybe I want to propagate the 2 public subnets. Maybe that's what I want to do. And I can even say, okay, maybe I want to propagate more than this. Maybe I want to propagate the private. But as at now, let's just put it at the public subnet for now. Public A and public B. So I've attached it. And then proceed to create. So it's actually pending. Let's refresh. It's pending. All these things that we are doing quickly, it's going to be interesting if you are using Terraform. Well, I like that we are going through this one after the other so that we'll be able to build up those steps. So this is my situation instance. I created 3 servers. I did it as server the last time, so I just want to put it power it on that because I can't leave it on since last week. So let's put it on. So these servers are servers in each of the VPC. So this one is on the web app VPC, as you can see. Let me go to the networking and see it's in the web app VPC. I get it. And for you to see this, it shows that this server is located in a public subnet because that's why I said your design is very, very important. Your design is very, very important. So for me seeing this IP of this guy, I know that, okay, well, this server is in the public subnet. I get my point. So same thing in the backend VPC. If I come to networking, I can see, okay, it's connected to this networking and you can see 192.168.1. So this one means that it's also a public server. So rather the database server, let's go to the networking. You can see that the third octet here is 2. So which means that this server belongs to a private subnet. So please just try and understand. This is just like a design methodology, just for you to be able to, okay, if you are troubleshooting, you actually, when you are doing a trace, okay, you know that, okay, this guy has to reach a public subnet, it has to reach a private subnet. So let me put this guy up there. Let me also start then. So let's go back to our VPN attachment, and it has successfully. It takes a while, it takes a long time, it takes some time. I think it's available now. Interesting. So let's attach the other guy as well. Backend attachments. So you select the same this thing, and the attachment type is VPC. And you choose the VPC that's the backend VPC itself. And it's trying to load up the AWS Transit. So, you know, the servers that wants to talk to are in the public and private subnet and all of that. So this one is in the public subnet. So we've chosen the 2 public subnet, the backend public subnet, and the backend, the 2 backend public subnets. So now it depends on your design. Maybe you want to propagate the private subnet or the public subnet. So it depends on you. So it's something that's your will, just your own design. But the main thing there is, why are you doing what you are doing? Why are you propagating the public subnet? Why are you propagating the private subnets? Is that what you want? Where is your communication source and your communication destination? So those are the things that will prompt the actions you're going to take. So let's play the third one, last one, database. The database and attachments. So it's also the same VPC. Okay, we choose the VPC. So it's the private, so we can already have private subnet here because we only created the private subnet for the database there. So 3s are pending. So let's just wait for them while they come up. It takes some while. So I think all these my 3 servers are up. So my server is up. So the reason why I put these guys at on public subnet is that so that I'll be able to reach them from the internet. Do you understand? So that I'll be able to reach them from the internet. We can do it in a way that we might have like a dump server that will be able to, something like a DMZ, that will be able to connect to all those VPCs at the same time. But don't let us put it in that way for now. Let's start. So this web app server, I have my PPK file, my PEM file. That's my private key. So I should be able to connect to this web app server from the internet. Same thing as my backend server. I should be able to connect to it over the internet. But My database, you can see that there is no public IP, it's in a private subnet. So I cannot reach it from the internet. So it needs to be able to reach privately within the network. And also, I was able to explain the connections via internet and the connection via VPC to VPC within the AWS. So you can only reach this guy if you don't have communication among the VPC. You can only reach anything here on the public leg. So let me just let's load in. Let's use our putty. Can you see my putty session? Can you see my putty session?
Yes.
I don't know. Can anyone hear me?
Yes.
Okay, so last week I showed you how to use. I'm just trying to use Putty. You can use your pen file. You can use all of other things. So this is your pen. This is your Putty session. Just want to give up that I'm not here before. So you have to generate your PPK file, your private key file. Once you create a server on AWS, you get a pen file. But there's a Putty generator where you can generate a PPK file for people that want to use Putty. And there is an option for yourself on AWS. You can either choose the PEM format or the PPK format. That's the private key format. So if you are using a Putty session, just come to click on SSH authentication credentials and you load your private key destination there. That's how it works. So let's come back and let's me open it. So let me accept the connection. So this is an Ubuntu server. So Ubuntu will be the username. So you can see I'm in now. I can log into this server. So the server 10201.5. You can see the name 10201.5. I can log into it. And from this guy, I can ping internet. Ping google.com. You can see that I can ping internet. I can ping everywhere. You can see that. So, but let me try to ping backend server. Let me try to ping it. I can ping it on the public IP, but without the VPN communication, the transit gateway communication, I might not be able to ping it on the private IP. But for the public IP, I can ping it because this guy is accepting connection over the public internet. So you can see that I can ping this guy over the public internet. But why will I be reaching a server? You're on the same AWS. Why will I be going through the internet to reach it? Doesn't add up. So that's why we need to do what we call the inter-VPC communication. That's where we have the VPC peering part and the transit gateway part. So now let me try to ping this backend now with the private IP. Let's see if it's going to be reachable. Sorry. Can you see that it's not reachable? Can you see? So you can see that it's not reachable. So I'm trying to ping the backend server from my web app. I can't reach it. I can't reach it on the private link. So that now comes to, okay, let's see our transit gateway connection. So the transit gateway is going to do the magic for us. Can everyone hear me? Are we together? Are we following? I want reactions so that
Yes, sure.
I'll know if I should just proceed.
Yeah, we can hear you.
Okay, all right. Okay. So let's cancel the ping. So you can see that several packet was transmitted and nothing was received. So let's come to our transit gateway. Let's check all our attachments. Nice one. All our attachment is there now. Interesting. So now we need to now go to the route table. That's where the manipulation, the customization comes in. So let's come to the route table. So you will see a default route table there already now. You see the default route table. So let's rename it to default route table. Is my default correct like this? Okay, I think it's correct. I don't know. It's a bit slow. I don't know. Let's just wait. So this is my default route table, right? Are we good? So now we need to associate. That's the first. Don't forget, associate. What are we associating? So we need to associate our attachments. Am I communicating? So we need to associate this default route table. This default route table now, we want everybody to be able to connect. Every VPC that we attach, they should communicate with themselves. So now let's start. So we come to association, you start associating them one after the other. And it's even associated already. So is it because, and you know the reason why this guy was associated? Because in the default, when we're creating the default route table, we actually said we should do a default association when we're creating the default route table, creating our transit gateway in the beginning. So we can see that all these guys are already associated.
Sorry,
And
it's
you can
a
also
bit
see that.
confusing. Can you hear me? Sorry to interrupt.
Yeah,
It's a
yeah,
bit confusing.
yeah.
What's the difference
Yeah.
between attaching the VPCs to the transit gateway and then these associations?
Okay. The first thing is that, I told you that when we're creating this transit gateway, there's an option by default. It should associate and also it should propagate. So any attachment that you create here, it's going to automatically associate it to the route table, the default route table. I don't know if you get my explanation. So this route table, we met this route table here. It's a default one. So by automatic doing our initial setup, we've already ticked it. There was a box there. So it's automatically going to associate all the VPC that we attach, because we need to attach first. We need to create that VPC attachment first. So the VPC attachment that we did has been automatically associated to this guy because we already tick it up in the transit gateway creation when we are doing it at first. So you can see that it has been associated, it has been associated to this transit gateway. You can create a VPC transit gateway normally, and you won't associate it with any VPC attachments. You are the one who will now start associating it by yourself one after the other. But when we're creating it at first, we tick that box. Okay, anything it wants, this guy, it should do like a default association and propagation for us. I don't know if you get my explanation. Yes. Association. I think association means that you are associating the transit gateway to your VPC. Transit gateway is just like a box. So okay, what you associate to, okay, I want to associate the web app VPC to it. So I want to connect the web app VPC to it. That's meaning of association. I get my point. I want to connect the backend VPC to it. That's meaning of association. If you don't associate, there is no way you will, the transit gateway will know about the route or about the routing table. Do you get my explanation? Hello, are you there? I think somebody asked a question. Is it Justin?
Yeah, I'm with you. I think Justin was
Okay.
the one. Yeah.
Okay. So now, and as well, the propagation. Now let me just calm down on this. You know, it also took me a while before getting this concept very well. So propagation means that what I want to talk to. Now see it in a way that attachment, transit gateway is has been the VPC has been attached to the transit gateway, which is fine, right? But propagation means that what route is it propagating? Okay, if anybody wants to reach, propagation means that okay, if you want to know about mail, come through this guy. So if you want to know about database VPC, come to my transit gateway. If you want to know about web app VPC, come to my transit gateway. Because we are doing like a default route table, all of them need to communicate to each other. That's why it seems confusing now. So once we start doing segmentation, to understand it very well. But propagation means that okay, tell everybody that I have a route to web app VPC. Tell everybody that I have a route to database VPC. Tell everybody that I have a route to backend VPC. That's what propagation means. I get my point. So is that propagation that is going to use to tell, okay, is attachment that, okay, well, this guy is a route to from web app VPC, okay, you attach to it, you send it to the attachment. I don't know if you get my explanation. Yes, exactly. It's just like advertising. I don't want to be bringing network terms. Yeah, so that's why I'm just trying to use all those basic terms. So just like advertising the routes. That's what propagation means. So propagation is different from association. Please let that one be known very well. Propagation is different from association. So your association is for attachments. So now, don't worry, don't worry. Don't be confused. You're going to get it. If you come to the route, you see that all our routes will be there now. So you can see that all our routes are there. Can you see? All our routes are there now. You know, I didn't do anything on routes. You know that I did not add any route. I did not add route at all. It automatically propagated. So it shows us automatically. So that's one of the dynamics of transit gateway. It learns the routes and propagate it by himself automatically. So now let me go back to my front end server. So let's ping the back end again. Let's see if it's going to work. It's not working. No. What's the issue now? I want someone to tell me straight up what's causing this guy now. It's not working. What's
Routing
that?
table, the routing table on the VPC.
Exactly. So the routing table on the VPC, we need to attach it. So what are we going to do on the routing table on the VPC? Just one step. So let's go to the VPC. So let me just click a new tab so that I want so this is the last stage to do. Not no stress. So because let's do something here. Let's do a trace. What's that? This puts it. I don't know. I want to cancel. Let me expand it. Guys, and do a trace path. It's hanging up. Maybe it's my name. Let's say this is good. So this page, and this page is loading up. Or if I do a trace, trace paths, you see that it's going to be dropping on the gateway. So from his own VPC, he doesn't know where to go. So as you can see now, you can see that it's dropping on the gateway. This is the gateway of the VPC. I explained it when we started our session. So the .1.1 is the gateway. So you can see that it's dropping on the gateway, right? So which means that this guy is not leaving the VPC. So from his own route table, he doesn't know where to go. He doesn't know the next guy to go. So that's why you need to come to the VPC, which is the web app VPC. You need to come to the route table as the web app public route table, because we are trying it from a public server. So you come to the route, you edit the route, you add route, and you put 192.168.00/16. And the last time I was saying this thing, I was telling you that we are going to explain each of these targets, the core network, the egress, and all of that. So now I think we've done peering. Now we are doing transit gateway. Maybe the next time we'll be doing gateway load balancer or network interface. So now let's do transit gateway now. You just click on your transit gateway. You can see that it automatically picks the attachments. So this is the transit gateway, but this is the attachment for this VPC. So that's why you see it there, but it's automatically your transit gateway. So this thing is still like representing your transit gateway. So once you attach it and you save, so now let's do our trace again. Our trace is not going yet though. Let's wait for a while. Okay, there might be like a this thing. There might be like how like an asymmetric routing, because we are just doing route table to this guy. We're not doing it from the other side as well. So we need to adjust it on the other side. So now let's go to this other guy, to the backend public route table. And we're going to add the 10.200 as well. 10.200.0.0/16. So you're going to see only one there, only one transit gateway. That's going to be these attachments. And save it. So let's do our trace. Did I enable ICMP before? Like not enable it, it might not go. Maybe I didn't enable trace in my security group, but let me ping it. Can you see that the ping is reachable? So the reason why the trace is not showing is on the security group, I did not allow ICMP before traffic. So I only allow ping. So that's why that's why the trace was not going. So we can see that the ping is going fine now. So same thing, if I log in, let me log in to the backend server and ping the other guy. So let's get the web app, the backend server. Let's get the backend server. Let's log into it. So we can only communicate to the public leg. So it's also the guys also an Ubuntu server. So same thing. If I try to ping my web app, my front end guy, once I drop my front end, my web app server, if I try to ping it, they are on different VPC. So if I try to ping it now, and you'll see that it should be reachable. So let me edit my security group to include ICMP for trace. And it's all ICMP now. I think we should be able to reach. I don't know why the trace is not working. Let me try to trace again.
Hello, Solomon.
Yeah, I.
Yeah, I'm lost.
No.
Oh, sorry. What's all this your backend function?
Hey, how do we start to? Uh, are you joining us for the first time?
Yes, now. Who you know, sir? You know now.
Okay, so what happened is that all these guys are servers in each of the VPC. So
Okay.
all these we have 3 VPC. Let me go to this slide. This is the VPC we have. This is our connection. Hmm? So we have 3 VPC. There's a server here in this VPC. That has a web app VPC. That's web app server. We have a server also in the backend server. I also have a server in the database. So they are in different, and by default, VPC does not communicate to each other. So what we want to achieve is I want to achieve an inter-VPC communication among these guys.
Okay.
So by default, so last week we did peering. We had VPC peering. We did VPC peering. So we were able to achieve that VPC peering. But VPC peering, it had some bottlenecks. So that's why we are using Transit Gateway.
Okay.
So what we first established now, what we first established now is that we want to be able to ping all of them from each other.
Okay.
That's the first thing. So we want to be able to ping all servers among these 3 VPC. All of them should communicate. I think this is the implementation we are doing. So this is what we are now. This is where we are. We want to test connectivity across the 3 VPC. So after then, we'll now limit it to these 2 criteria. I get it.
Okay.
So first of all, we want to do it in a way that we want the 3 VPC to communicate to each other. Then the second thing we are doing now is that we want only the web app to talk to the backend only. And also want the backend to database only. I get it. So that's what we want to achieve. So on this guy now, so this guy is on the front end. Front end is the same thing as web app. This is the server.
Okay.
This is the server in the backend, and this is the server in the database. So we are trying to reach them via their private IP.
Okay, I think I got that here. Okay.
So this guy here now, this 10201, this is this is the web app server. You can see that is within this VPC. This is I don't know. This can you see that this guy? If you check the networking, you see that the networking is a web app VPC. So this is 10201.5. So this is the server. This is the server. So the other server, which is the backend, 192.168.1.28. This is the server. This is the server. So we can ping both of them after we've configured our transit gateway from each other.
Okay.
So the next thing now is that we need to do it for database. We want to also be able to reach the database from all of them. So we need to update the route the same way we did it earlier. I would have said I should do it at once, but just for explanation, that's why I'm
all right.
One after the other. So on the back end as well.
Okay.
Let's
hi Suleiman. Sorry to interrupt you.
Okay.
So you had to add routes for each VPC to the transit gateway. Is that correct? You had to do that.
Yes.
Okay.
Yes, you need to do that. Yes, you need to do that. Yeah. So that's why in your design, some people their design they always put all their VPC should be in like a super network. And how will I explain this thing? Their VPC will be on the super net. All their VPC will be on the super network, and they can use like a very large CIDR ring to advertise. Instead of me doing one after the other, you can just consolidate all the 3 subnets together into one CIDR ring and advertise it together. But you know it's possible.
Yeah, for sure.
So that's what some people do. So it just depends on your design and the way you look at it, and you can just it's something that you can just based on your own design. So now this is database VPC 172.30, 172. 30.0.00/16. So Transit Gateway, same. I think that is the same Transit Gateway. So which route table is this one I'm editing of? This is the backend public route table. Okay. Now let me do for the web app. So I'm just trying to advertise the one for the database. So now let's go to the database route table now. That's the last one. The database doesn't have any public route table. So I can't reach it over the internet. So let me try and ping the database from all of them. This is the database IP address. So let me try to ping it from the web app. This is the web app server. Let me just expand my history. So I'm trying to ping the database from this from the front end server. That's the web app. It's not going on. Why? Can somebody tell me why it's not going? Can somebody tell me why it's not going? I can't reach it from the web app. Let me show you something. I can't reach from the web app, but let me try
The routing
back
side.
What do you say? It's not a routing issue. It's not a routing issue. But I should be able to reach from the back end. Why? I said this to the last class. Why?
The subnet of the
No, it's not a subnet. It's not meant. If anyone that is in this last class would actually know the reason. I can reach it from the back end, but I can't reach it from the front end. And I've done my routing. My routing is fine. I've done everything. What's the issue? I've advertised my routes. I've done everything.
It's not a security group.
Exactly, the security group. It's a security group. Because if I go to the security group of this guy, like I remember the last week, let's go to the database server. This is the security group. I only did it for this guy. You see on the security group, the ICMP is only from, you see, I explained that the security group is an instance level security. So I only whitelisted for the for this guy's submit. I didn't do it for the front end. So I need to do it for the front end now, so that I'll be able to ping it. Then 200.0.0.16. Yeah, good. Let's save the rule and let's come back. Yeah, we should be able to ping it now. Yeah, we are good. So I think with this explanation now, we can see how to troubleshoot end to end. If your routing is not going, it's more likely the security group, the network is here. Once you've done your routing fine, the reception here is very slow. Oh, that should be network. Is anybody experiencing like slow reception? Hello, can anyone hear me? So as you can see now, I can ping my database. Okay, the video. Okay, I think that could be the bandwidth. That could be the bandwidth.
Yeah, maybe I think it's the Nitayos network. It's quite fast for my end. Yeah.
Anybody else experiencing like a slow reception? Well, I'll still share the video at the end of the class. So this not to so but what we're able to establish that we can reach everybody. Now everybody can reach themselves. Like it's like a free express now. Everybody jam everybody. They can all connect, but on the typical architecture network, you should not have this kind of setup. You cannot have this kind of setup because InfoSec will flag you. Do you understand? InfoSec will flag you. So, but what I try to point out now is that I'm trying to point out the reason, the default route of the transit gateway, how it works. So maybe you just want a default communication across all your VPC or across all your VPN attachments. Do you understand? So this guy will just give you like a default communication. It's going to help you to propagate. It's going to help you to associate everything at once. So this is the default way, but we don't need the default way. We don't need it. We don't need the default way. We don't need it. We don't need the default way. So now let's now go to what we planned. And what do we plan for? What was mentioned in our use case is that we only want the web app to reach backend, and we only want backend to reach the database. Are you getting my point? So this is what we want to achieve. So we've actually achieved the default. Nice one. We are good. But what our intention is, we want to be able to reach web app to backend and backend to database. Now let's go back. Now let's come here. So the first thing you're going to do is that I'll need to associate it. I want to delete the association. I want to delete the association from the default route table. So once I delete the association, propagation also should go away. And the propagation as well. All these guys was done default for me earlier, so that's why. So once I remove the propagation, you will see that you won't see any route again. If you go to the route, you won't see anything again. Everything has gone. You can see that there is no route again. No route again. So now let me delete the default route table. Delete. Okay. We're not able to delete it though. No wahala. Let's leave it. So if you can't delete it, let's leave it. At least we did not attach anything to it. So now, let me now create a scenario for you. I want to explain something, and I want you to get me very well. Now, I want to create. Let me see if I can open like a Jamboard. I can actually create a Jamboard, but let me just try to point on. I need to write something. So now we want to create our own custom route table. You know, I explained in our explanation. So what I want to do is that I want web app to communicate to backend. So now I'm going to create a route table. Oh, okay. Okay, thank you, Tayo. So what I want to do is that I want web app to communicate to backend. I get my point. I want web app to communicate to backend. So I'm going to create a route table. So I'm going to call it web app routing. I'm going to choose the transit gateway. I'll create the table. So I'll create the table for all of them, for 3 of them. The backend. Sorry, choose the VPC. Sorry. And the last one is database. So now I have all these guys now. So now let's come to the web app. So web app, what am I going to associate to web app? I'm going to associate his own attachment to it because he's the owner, it's his own routing table. So now let's create association. So what am I associating? I'm associating the web app attachments. I get to my point.
No, can you take that again?
Okay, let me come again. So this is the web app. I get it. So I'm trying to create like a customized table now. So I create a default a web app route table, right? So I can do it in 2 ways. I'm doing it one after the other now. I can do it in 2 ways. I can do it in a way that this is web app route table. This web app route table. So I'm going to attach the VPC, the web app VPC to it. That's going to be the attachment association. I get my point. So this is all these route table are customized route table. It just depends on your own design. Now, this guy should be here. Sorry. So this web app route table now, I have it already here. Yes. Who is the owner? Who is the associated VPC? So the associated VPC is the web app VPC. I get my point.
Yeah.
So what am I propagating? What I'm propagating who needs to talk to web app? Guys, you're not playing with me. Who needs to talk to web app VPC?
The backend.
Yeah,
Exactly. So you are going to propagate the backend VPC, the backend attachments. I don't know if you're getting my point. Or is it's getting complex, right?
No. For me, it's clear for me.
So this is the web app. I'm doing it one by one. I'm just trying to explain the concept of association and propagation. So see association as okay, this is my route table, I'm the owner. So you associate the VPC that want to initiate the communication. You associate it to the route table. But what you want to talk to, the subnet, the VPC you want to reach, that will be your propagation. So same thing, this is web app. Same thing, I'll go to backend route table. I'm going to associate what? What am I going to associate here? To backend route table.
Web app.
No.
Database.
No. I'm associating on backend. Which route table am I? Let me check. I'm on backend route table. What am I associating?
Oh, you're associating the
You associate
backend VPC.
for backend, you associate the web app.
No. For backend, I'm going to associate the backend attachment. I get me.
Oh, association.
But if I'm propagating, what will I be propagating?
Web app.
Exactly. I'm going to propagate the web app because what does backend needs to talk to?
Yeah, the web app and the database.
No, 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 no. No. Let's go back here. What is web app talking to here?
Backend.
Okay, web app to backend.
He's talking to backend. It's talking to backend. So if I'm on this backend route table, so I associate the attachment of his own VPC. But what am I propagating? I'm going to propagate what? The web app, because that's what. No, it's not database. Don't get it wrong. Just see it as, okay, who am I talking to? Is who you want to talk to, that's what you are going to propagate.
About the backend.
I get my point. Which is the backend. So you are propagating the backend. No. You start confusing me. Don't confuse me. So this is the backend.
I think the confusion is that, on backend we'll be talking to both front end, both the web app and the database. So I think
no. Okay, yes.
But for where we are at the moment, that we are doing web app for backend, so we shouldn't be talking of database. That's where
database. Yes, you are right. We are going to forget database as well, but not now.
Yes. Exactly.
Not now, exactly. I'm not even seeing that second question. So now let's just do that for now. So now you would see if I come to web app that table now, you see that what I propagate? I propagate the backend app. So you see that my route will be automatically come and see my route now. Which route is this guy? Guys, are you there? Which route is this guy route?
Sorry, I didn't get you.
What's this route? Which VPC owns these routes?
That's the backend.
Yeah,
exactly. And which route table I am now?
Web app.
Yeah, the web app route
Web app.
table.
Exactly. So it's automatically, so as long as I propagate what I need to talk to, it's going to automatically send me the route. I get my point.
Okay.
Yeah.
So now let's try it. So now let me go to backend as well, backend route table. And now I propagated back web app. Maybe the name I used, that's why it's somewhat confusing. So you can see that web app VPC, and I can see it in the backend route table. So now let's try our ping. Let's try our ping. I think this is backend. This is backend. This is the backend server. So let's ping the front end. I see that it's going. Hello. Hi, Jamie. Can you mute your mic? Hi, Jamie. Hi, Jamie. Can you mute your mic? Thank you. So you can see that it's going. If I remove these routes now, if I remove the propagation now, you see that it will go. Should I try it? So this is your custom route table. So this is where the bulk of the work comes to as the administrator. So you need to be able to, okay, what am I propagating? What am I associating? I get my point. You can still consolidate them, but if I start from consolidation, it's going to look very complex and it might look very difficult. So that's why I'm taking it one step after the other. So now, I create the web app right now. This is the web app is fine. This is the web app, right? That's fine. And I'm propagating the backend. So I'm communicating to the backend. That's the what I need to talk to, right? And also on the backend as well, what am I talking to? I'm talking to the web app. So I need to talk to the database as well, right? But don't let me do that. Let me just, I can do it in a way that I can change this guy. Let's change this guy now. I might not need the database route table again. So you now know what I will need. What I will need now, I'll just delete this guy. I'll just say web app and database. RT.
Web app
so what
backend.
I will now do is that, backend and database. So what I'm going to do now is that I'm going to associate what? I'm going to associate both backend and what? And database.
Yeah.
I get me. And what am I propagating?
Web app and database.
No. What I need to talk to? What do I need to talk to?
propagate the two subnets. The one for backend and
So
database.
no, you can't. Hold on. This is what I don't know. Let me remove it this route. I mean, it's getting confusing to you guys. Let me remove it and let me just do one so that it won't be confusing.
No, I mean the two VPCs.
So now backend now. You can see the backend now. Don't worry. Don't let us take it consolidation. Let me still take it one after the other. So now, but we've all understand that this is the web app route table. I've associated the web app, right? Web app attachment, right? And I've propagated what I need to talk to, which is the backend, right?
Yeah.
That's fine. So now let me go to the database. Let me associate the database attachments because this is the database route table. So let me associate his own attachment to it. So I've associated database route table to it. Right?
Sulaiman. Sorry to
let me go.
Hello,
okay.
Sulaiman.
Yeah, I'm with you.
Okay, so
yeah,
I just want to get some clarity. Is what we're trying to do manually now? What we're trying to do manually is that what the default route association and default route propagation that was enabled earlier? Is that what it was doing for us already?
Yes, that's what it's doing. But the default, all of them can ping each other. You need to now separate them.
Okay.
Do you get?
Okay.
The default one. In that default one, all the guys are associated and all of them are propagated with one single route table.
Okay.
So that's why you now need to start breaking them based on your own communication, what you need to communicate to each other.
Okay, got it.
So as you can see now, I'm backend. Hi, Gabriel. Let's see something. I can't hear you, Gabriel.
I was saying, so by default, the web app was talking to the database by default before this segmentation.
Default route, yes. But now you see now it's not talking to it. It's not talking to it anymore. It's
during the setup of the transit gateway.
Yes, we did it from the transit gateway. So this is backend, but let's ping the web app and the database. The database is not going. But that's the default on this guy when we want to create the transit gateway. But now we are breaking things down. So now we need to establish from backend to web app. Now let's try to establish from backend to database and database to backend vice versa. So now this is database route table. You've associated database as an attachment because that's his own route table, right? Now, what are we propagating? What is database need to talk to? Need to talk to which guy?
Backend.
Exactly. So we now come here and advertise backend. But that it will still be reachable because on backend we just propagate what?
Database.
Exactly. It will be reachable because now let me come here. You can see that it's still not reachable. I'm trying to ping database now from backend now. It's still not reachable. Even though I've created database route table, I've associated his own VPC and I've propagate. Okay, I want to talk to backend though. Okay, transit gateway. I'm propagating. I need to talk to backend. We're happy to find backend. But on backend route table, I've not propagated database. So there is no way my backend route table will be able to know that somebody is even database. So I need to now propagate database. Now come here, click on database attach rate and create propagation. So as soon as I do that, you will see the ping will be going. Where is it? So the ping is not going, Let's see. Are we doing something right? This is the backend, right? So now let's check. So now let's check. The ping is not going. So now let's check. Let's check the route we are learning. Let's check the route here. So we can see we are learning both guys, right? So it should be reachable. Can you see it's reachable? Maybe it's taking a while. No transit gateway now.
It's taking a
while to pop up the route to sync. So I'm just thinking that What's happening? So this is what we achieved now. You can see that with each VPC having its own route table, you can able to customize. Okay, this same thing is the same way if you have a VPN connection. Just see VPN as a VPC, as maybe you have a site-to-site VPN connection. This is the same approach as well. If you have a direct connect gateway, this is the same approach. So it's just about you now trying to, okay, on if you are even troubleshooting, so you can even check the route table, okay, what's associated to it and what is propagated to it and which route are you learning. So if you can try to, okay, this is what I want to talk to, let me propagate it. This is what I want to communicate to. So from what we just did now, even if I log into, this is the front end, the web app VPC, front end server, web server. I can't communicate to database. You can see that I can't communicate to database. Are you getting my point?
Yes.
Yeah.
So I've actually implemented what was assigned. Like the main reason of my implementation, I've actually achieved it. So it's just a matter of understanding the route tables. But the route tables, and you know that since I've done the route table on the VPC once, I'm not doing it. I'm not changing it again. Once you've done the route table on the VPC route table once, you're not changing anything again. It's not like I'll start modifying anything again. Anything I need to do will be within the transit gateway route table. Maybe another customer was now on board to your VPC. Maybe you have a new VPN connection and you want only this VPN connection to be able to reach your third-party router. Maybe your third-party VPC or your third-party application, and you have a VPC for it. So all you need to do is just to come to your third-party VPC attachment here and propagate. Are you getting me? And propagate your new VPN connection that is coming to your network. And that's all. So instantly they're going to have your connection. So the important thing there is you should understand attachments, propagation, and routes. Those are the three important important features of transit gateway. So if you now have a situation whereby you are having a route issue or there's a way you can now segment. So start checking, okay, on your VPC, do you have the route table? Do you have a security group in place? Do you have a network ACL? Is the transit gateway propagating the right route? You know, in each of these route tables now, I was able to confirm that all these routes are propagating. So I should be able to talk to this guy from my backend VPC. So I should be able to talk to the front end. I should be able to talk to the to the database. So it's trying to get the whole fundamental of this connection. So I think it's time for questions, right? Okay, let's have some questions. Hi, Dixon.
Hi, hello, Sulaiman. Thanks for this workshop. So, is it time to ask questions, or I just wanted to quickly ask a question?
Yeah, you can ask.
Okay, thank you. So I couldn't follow the workshop fully from the beginning because I was engaged with that thing, but I will get the recording hopefully today, please. Now, I wanted to simulate connection between an on-prem to AWS. Okay. I created using Transit Gateway. So site-to-site VPN using Transit Gateway, right?
Okay.
So I created a Transit Gateway. And then when I created the Transit Gateway, on the AWS side, I created Transit Gateway attachment.
Yes.
On the customer side, which I'm simulating using another VPC, I created another Transit Gateway attachment. So my technical lead was telling me that is wrong. So I want to get clarification from you. Is that it was saying that from the customer side, there's nothing that needs to be done about the Transit Gateway. It's just from the AWS side. So please clarify me. Am I not supposed to create a Transit Gateway attachment on the customer side?
Okay.
Yes.
Okay. Thank you for your question. So that kind of scenario, so you only need to do the transit gateway attachments on AWS. On the customer side, you just implement something called like a VPN connection, a site-to-site VPN connection. On the customer side, you don't need any transit gateway again.
How do I implement that? Because I try to understand how do I implement the VPN. I've created the VPN, the site-to-site VPN. I use OpenSwan.
So all you're going to do is that on the customer side, there is something they call the customer gateway. So the customer gateway is going to actually be the parameters from your transit gateway parameters. That's what you're going to input into the customer side. So what you are building at the customer side is only a site-to-site connection. But on your own side, you are building a site-to-site connection. On AWS side, you are building a site-to-site connection using transit gateway. But on the customer end, what will be seen is just a normal site-to-site VPN connection.
Okay, please, I have a request. I don't know when the recording when you finish this part, but I can quickly log into the account and just like the stuff is still there. I've not deleted it. Can we just like have a look and like maybe figure, because the thing I'm still not understanding it's up to this moment as I'm talking to you. So if maybe
both of them are AWS account, right?
Yes.
So, and it's a different account entirely, right? Just want to simulate a site-to-site connection with them.
No, the same account, but different, the same account, the same region, but different VPCs.
Different VPC. So, why do you need a VPN connection?
I want to be able to connect VPC A to. Sorry, I wanted to. No, I'm simulating AWS to on-prem. So on-prem network is VPC B.
Exactly. So you are simulating it as on-prem, right? Okay.
Yes. Okay. So that's why I need the site-to-site VPN.
So okay, I get it. So let me explain. It will be, we can do it maybe at the time, and do it after this session. So the something is that
okay. I will log into the account now. Thank you.
Yes, we will look at it, but let me explain something. You can't since it's an on-prem, the best thing is to have maybe a site-to-site connection, because let me just come here. Let me come to this guy. You can see a VPN connection. Create VPN connection. You can see in this VPN connection, you put your name, you put your transit gateway, since you are the source. You put your transit gateway and customer gateway. That customer gateway will be the customer gateway you've created in that, will be the virtual private gateway you've created in that other AWS account. I don't know if you get my point. That customer gateway is going. This customer gateway is going to be the customer gateway, the VPN gateway of that remote account, and you put your CIDR range, your thing, put everything in there, and you create your VPN connection. But it's something we can look at. Let's go to the next question because of time. I Justin, you have a question.
Yeah, so I just wanted to confirm, right? So if you're
kindly open your mouth. Good. Kindly nod.
Oh, can you hear me?
Yeah, I can hear you.
Yeah, so if you have a direct connect, if you have a direct connect, right? Are you going to be, and then you have VPCs or subnets that you need to propagate on-prem, right? Okay. Are you going to be adding your direct connect as an association and a propagation as well on the transit gateway routes?
Yes. Yeah. Thank you for that question. So the same way you have, so the first thing you're going to do is that you come to your transit gateway attachment. You create an attachment for that, your transit gateway. You can see you create let's attachment tag, direct connect. So in this place, you can put your connect attachment ID. Once you have, if you have a direct connect gateway, it's going to populate here automatically. But I don't have it here. But on your account, I believe you should have it. So it's going to populate this direct connect gateway automatically here. So you are adding the direct connect as an attachment first. So after taking it as an attachment, you can then now doing the association and the propagation on your route table based on your preferred routing. Do you understand?
Okay. Just the same way you add all the VPCs as an attachment first, right?
Exactly.
Okay. Cool. Thank you.
You're welcome. So I think it's been a long ride. So are we waiting for Dixon to share his screen so that we can take it together? Or,
I want to. Is there probably could